Have you ever noticed how some of the simplest questions about space and the universe are actually the hardest to answer? You'd think science would have figured everything out by now: rockets, black holes, even landing robots on Mars. But when it comes to some very basic mysteries, even the smartest scientists in the world still don't have clear answers. Today, let's talk about 4 of those mind-bending mysteries. They sound simple, but once you look closer, you realize they're still unsolved. Let's start with time. Every day, you feel time moving forward. You wake up, go to work, and grow older. But have you ever wondered why time only moves one way? Why can't it go backward? In physics, most equations work just as well forward or backward. If you roll a billiard ball in reverse, the math still checks out. But in reality, we never see time reverse. Broken glass doesn't reassemble, ashes don't turn back into a burning log. Time always flows forward. Scientists call this the arrow of time, and they've been trying to explain it for centuries. The best explanation we have is something called entropy, the idea that disorder always increases. Imagine your room. If you leave it alone, it gets messier, not cleaner. That's entropy. Since the Big Bang, the universe has been moving from order to disorder. That's why time has direction. It's tied to the increase of chaos. But here's the big question. Why was the universe so perfectly ordered at the beginning? If the Big Bang exploded into randomness, why didn't everything start messy? No one knows for sure. Now, let's look at our own star, the Sun. You'd think the closer you get to the Sun, the hotter it becomes, right? But here's the strange part: the Sun's surface, the part we see glowing in the sky, is about 5,800 Kelvin. Incredibly hot, but just above the surface, in a layer called the corona, the temperature skyrockets to over 1,000,000 degrees Kelvin. How can something get hotter as you move away from the heat source? That makes no sense. Scientists have been puzzled by this for decades. One idea is magnetic reconnection. The Sun's tangled magnetic field lines snap and reconnect, releasing bursts of energy that heat the corona. Another idea involves Alfvén waves, invisible energy waves that travel along magnetic fields, carrying heat upward from the Sun's interior. NASA's Parker Solar Probe, the spacecraft flying closer to the Sun than ever before, is trying to uncover the truth. But for now, the mystery remains. Next, look up at the night sky. What do you see? Stars. And a lot of darkness. Here's a simple yet puzzling question: if the universe has billions of stars in every direction, why is the night sky dark? Shouldn't the entire sky be glowing with starlight? This question, known as Olber's paradox, sounds simple but forced scientists to rethink everything about the universe. If space were infinite and full of stars, then every line of sight should eventually hit a star. The whole sky should shine as bright as the Sun. But it doesn't. The answer came when scientists discovered that the universe is expanding, and had a beginning, the Big Bang. The light from the farthest stars hasn't had time to reach us yet because the universe is only about 13.8 billion years old. Plus, as the universe expands, light stretches into longer wavelengths, beyond what our eyes can see. So much of that starlight is now hidden as infrared or microwave radiation. Finally, let's talk about gravity, the simplest yet most mysterious force of all. Drop something and it falls. Planets orbit the Sun, the Moon orbits the Earth. Newton gave us formulas to describe it, and Einstein showed that gravity is really spacetime curving around mass, like a trampoline bending under a bowling ball. But here's the kicker: we still don't actually know what gravity is. We can describe how it behaves, measure it, predict it, but not explain why it exists. Is it a fundamental force built into the universe, or something deeper? When scientists try to merge gravity with quantum mechanics, the laws of the very small, the equations just don't work. The universe isn't just complicated in the far reaches of black holes or distant galaxies. It's mysterious even in the simplest, everyday things. Why does time move forward? Why is the sun's outer layer hotter than its surface? Why is the night sky dark? Why do things fall down? These sound like questions a curious child might ask, yet the greatest minds in history are still searching for the answers.